Chapter 13, problem number 28. At the Earth's surface, a projectile is launched straight up at a speed of 10 kilometers a second. To what height will it rise? Ignore air resistance and the rotation of the Earth.
Problem asks us to find how far an object will fly up if it is given a initial velocity of 10 kilometers per second. Since normally we work in meters per second, we're going to convert between kilometers and meters. Multiply by 10,000 gives you 10,000, or multiply by 1,000 gives you 10,000 meters per second. From the tables in the book, we know that the mass of Earth is 5.98 times 10 to the 24th kilograms. Radius of the Earth is 6.37 times 10 to the 6 meters. This is a blank sheet of paper. The equations we're given from the book is that the potential energy of gravity is negative g m1 m2 over r, g being the gravitational constant, m1 being the mass of the first object, 2 being the mass of the second, r being the radius that separates the two of them, or distance that separates the two of them. K is the kinetic energy, 1/2 mv squared. M is mass, v is velocity. The initial kinetic energy plus the initial gravitational energy plus delta E mch, which turns out to be 0, is equal to the kinetic energy final plus the gravitational energy final. We know this because energy is conserved in the system. We plug our values in terms of formulas. 1/2 mp v squared plus negative g mp me over re, where re is the radius of the Earth, mp is the mass of the projectile, and me is the mass of the Earth. Negative g mp me over r plus h on this side, because it's going to go up by h meters. We need to find h. Thus, we solve for h. First thing we can do is factor out the mass of the projectile. mp, they cancel out. 1/2 v squared minus g me over re is equal to negative g me over re plus h. What we're going to do is we're going to switch this part and this part. We're going to multiply both sides by this part and divide both sides by this part, which yields this. Pretty complicated. That's okay. We have calculators. Subtract re from both sides, and then plug the values into the calculator. This gives us a value of h is 2.52 times 10 to the 7th meters.